Good day, everyone. So, I will discuss my answers regarding the activity 5 in organic chemistry. So, in number 1, line bond structures appear to imply that there are two different isomers of 1 to 2 bromobenzene, one with a bromine-bearing carbon atoms joined by a double bond and one with the bromine-bearing carbons joined by a single bond. In fact, though there is only 1 to 2 dibromobenzene, the two structures are resonance forms, not isomers. So number 2, what is the IUPAC name of the following compound? The nitro group and chloro group are on carbons 1 and 3. They have a meta relationship. Citing the two substituents in alphabetical order gives the IUPAC name M-chloronitrobenzene. And number 3, show the mechanism of the reaction of benzene with fuming sulfuric acid to yield benzene sulfonic acid. The reaction of benzene with fuming sulfuric acid to yield benzene sulfonic acid is a typical electrophilic aromatic substitution reaction, which occurs by the first adds to the aromatic substitution reaction, which occurs also by the usual two-step mechanisms. So an electrophile first adds to the aromatic ring and H plus is then lost. In suffocation reactions, the electrophile is HSO3 plus. So in number 4, what products would you expect to obtain from the reaction of the following compounds with chloromethane? So in letter A, benzene, it's ethyl benzene, and in letter B, p-xylene. So the answer is 2-ethyl 1,2,4-dimethyl benzene. So number 5, which would you expect to react faster in an electrophilic aromatic substitution reaction? Chlorobenzene or ethyl benzene, chloro substituent is deactivating, whereas an alkyl group is activating. Thus, ethyl benzene is more active than chlorobenzene. So number 6, what products would you expect from bromination of aniline? So an amino group has a lone pair of electrons on the nitrogen atom. It is ortho and para-directing, and we expect to obtain a mitro of O-bromoaniline or aniline and P-bromoaniline. So in number 7, what aromatic products would you expect to obtain from oxidation of the following substances with potassium manganate? So the aromatic products are shown in the file. I attach the products that I expected to obtain from oxidation of potassium permanganate. And number 8, there are 3 resonance structures of naphthalene, of which only one is shown. Draw the other 2. So in this problem, I draw the 2 resonance structures of naphthalene, and you can see it in the file. So number 9, synthesize M-chloronitrobenzene is starting from benzene. So there are 2 substituents on the ring, chloride group which is ortho and para-directing, and a nitrogen dioxide group which is meta-directing. And we can nitrate chlorobenzene because the wrong isomers O and P chloronitrobenzenes would result that chloronization of nitrobenzene should give the desired product benzene, which can be nitrated. Lastly, in number 10, synthesize p-bromobenzoic acid starting from benzene. So there are 2 substituents on the ring, a carbon group which is meta-directing and a bromide atom which is ortho and para-directing. We can't brominate benzoic acid because the wrong isomer or M-bromobenzoic acid would be formed. We have seen, however, that oxidation of alkyl benzene side chains yields benzoic acids. An immediate precursor or our target molecule might therefore be p-bromotoluene. So perhaps toluene because the methyl group would direct bromination to the ortho and para positions, and we could then separate isomers. Alternatively, bromobenzene might be an immediate precursor because we could carry out a Friedel-Crafts alkylation and obtain the para product. Both the methods are satisfactory. Benzene, which can be methylated in the Friedel-Crafts reaction, benzene, which can be brominated. So, I get the answer based on my enough understanding. So, thank you for listening.